Hi guys, today we will be knowing why strain, displacement and normal force treated as independent variables among stress strain, force displacement and friction normal force. So let us start our discussion from stress strain diagram. So the present figure represents a stress strain curve, and we place the strain on x-axis and stress on y-axis. We treat x-axis as independent variable and y-axis as dependent variable. So before having of a discussion between the stress and the strain, so let me start knowing about why the x-axis has been placed as an independent variable. Every variable has to follow the time line, progressing from left to right. And we can place on any one of the axes the time line, either on the horizontal or on the vertical. So the results will not be varied from one to the next axis, but only for the easy convention, in the sense for the results or the observations to make it easy understandable to the others, we are going to treat the x-axis itself as a independent variable and y-axis as a dependent variable. The present figure represents the behavior of a material because of the applied load. We state that when the tensile load acts on the object, it gets deformed. Because of the deformation, the internal molecules of an object it start resisting the deformation. We state very clearly. So as the object gets deformed, there's a reason the internal molecules of an object it start resisting the deformation. We state the strain acts as an independent and the stress acts as a dependent variable. In the force displacement curve, force will be treated as a dependent and the displacement as independent. Basically, we should concern about the behavior of a materials but not over the forces. So let me start discussing between the stress strain and the force displacement curve. In the stress strain curve, so we plot a slope and the slope defines it's all about the Young's modulus. So Young's modulus is the ability to resist the changes in the length. So which is a measure of the elasticity, is a measure of the behavior of an object. So similarly, if you observe the force displacement curve, so the curve also defines the slope and the slope itself defines about the stiffness, which is the behavior of a material. So let me know what you mean by the stiffness factor. If you observe the stiffness factor, so the Young's modulus plays a vital role to define about the stiffness factor, which is used to characterize the stiffness of the material. In the sense where the stiffness factor as well as the Young's modulus is majorly is defined to describe the behavior of the materials. It defines the slope over the stiffness, and we should not consider it as a spring constant because the spring constant will be differ in a few things over the stiffness. So let me have the difference between the spring constant and the stiffness. The spring constant is a property of the object. The stiffness factor is a property of the material. That's the reason why we have to consider the stiffness, because we are under the behavior of a material. So we should not consider it as a spring constant, but it should be as a stiffness, because we are not concerning over the object, but we are going to concern over the behavior of a material. Let me describe the force displacement curve with a small video. So this is a machinery, is a force transducer, and we kept a spring over the machinery just to know the resistance of a material. In the sense, we are under the behavior of a material, but not to describe over the object. So it says very clearly, so we are under the stiffness of an object. So whenever the displacement of a machinery it starts moving from one point to the next point, then we will be knowing the resistance of the spring. In the sense, as here the displacement takes part as a independent, so based upon the changes of the displacement, so we will be knowing the resistance of an object. So we treat the force as a dependent here. There's a concern that why we treat the force as a dependent. So because of all the thing is to only to describe about the stiffness. So whenever the displacement start change from one point to the next point, so because of the changes in the displacement, so we are knowing the resistance of a material. In the sense, we are going to define the behavior of a material, so we treat the force as a dependent. Similarly, let me start discussing about the friction and normal force graph. In the present friction and normal force curve, so the friction force will be treated as a dependent and the normal force as a independent. So because of the normal force itself, the friction force it starts generate. So in the present figure, one of the object it start interacting towards the next object. As the object consists of roughness as well as the sharpness, that what we call as asperities. So asperities is nothing but it's the roughness and the sharpness of the object. So when the object plays over the next object, so the interaction of the atoms will be taken place. So what do you mean by the interaction of the atoms? So generally the atoms consist of the protons, the electrons and the neutrons. So the protons are the positively charged and the electrons are the negatively charged. So the electrons of the first object will repel over the electrons of the next object, and the electrons of the first object will attract over the protons of the next object. Similarly, the protons of the first object will repel with the protons of the second object. Same as the protons of the first object will attract over the electrons of the second object. In the sense that where one object to the next object, it starts repelling from one to the next. Let me know that how the friction force describe or it depends over the normal force. So if you observe the second figure, so the first object will be moving over the second object. So as if the two atoms were strongly bonded, in the sense the interaction of the atoms from one to the next was a strongly bonded, then to move the first object we required a very high force. In the sense the friction force was a very high. If the interaction of the atoms, in the sense the bonded between from one to the next was a very less, then the friction force was a less, which means that when the normal force was a high, the friction force will be high. When the normal force was a less, the friction force will be less. There's a reason that why the normal force acts as an independent and the friction depends over the normal force.